So today we're going to review independent and dependent in story problem format. We've talked about it when it's on the graph. Clearly I have that identified here. The independent is your x-axis and your dependent is your y-axis. And it talks about the independent is the one that changes your dependent variable. So we're going to use those to kind of help us figure out which part of the equation is which. So this first equation says a lawyer's fee is $180 per hour for his services, and the total cost would be C. Identify the independent variable and the dependent variable. So clearly, first thing you have to do is identify the two variables. So you have hours and cost, and then we're going to write an equation. So sometimes I find it easier to talk about the equation first, and so I'm going to go ahead and write that the total cost is going to be equal to 180 per hour. So if I were to graph this one, hours would go along the bottom, and the money or the total cost will go along the side. And automatically that tells me which one is the X and which one is the Y. Again, the number of hours that you work affects the amount of money that you make. So what's a reasonable domain? Well, it's time. So you have to think about it needs to be integers, well, probably actually whole numbers. So a reasonable domain here would be input values, would be whole numbers. And in some cases, you wouldn't even probably go down to the minute. Lots of places bill by the half hour or by the 15 minutes. And so you could list 15 minutes, 30 minutes, 45 minutes, an hour. Those could be my potential input numbers. You would not have any negatives because you can have negative time. Reasonable ranges would then be also whole numbers because you're going to take 180 times a whole number. So that would be whole numbers as well. And again, if you wanted to give some examples, we could do that. Oops, let me put that spelled correctly. So for instance, this could be something like 0 minutes, 15 minutes, 30 minutes, an hour. So how much money would you make if you worked for 0 minutes? You would make 0. 15 would mean you would take 180 and you would divide it by 4, which is going to give me something like $45. And half of that would be 90. A whole hour would be 180. So you could ... continue the pattern out and list me out all the possible X and Y values. All right, let's try a different one. I guess let's try number 2. So I have number 2 and number 3 are your turn. Kate says she's earned $7.50 per hour each for her total amount of pay. Again, that one's almost the same that we have before. I think the only thing I want to highlight on this one is the domain and range. Clearly, we would have integers, or we wouldn't just have whole numbers. We'd have positive rational numbers. Okay, so let's talk about rational numbers, because a rational number would normally include whole numbers, all counting numbers. It would also include all fractions and all decimals. It would also include the negative of all of that. So you could have -1, -2, -0.5, -0.4. It would include all the negatives as well. So that's why I mentioned that this would be positive, because you can't work a negative number of hours to get negative. But because our pay is going to be multiplied by 750, which is a decimal number, you need to include decimals in your answer. Whole numbers would not be acceptable. All right, so let's talk about function notation in this format. So again, it's pointing out that the X is your input and your solution is your output or your range. And so when you're going to try to do this example, it says, write an equation in each sentence in function notation. Find a reasonable domain and a range for each function. So the temperature early in the morning is 17 degrees. The temperature increases by 2 degrees Celsius for every hour for the next 5 hours. Write a function for the temperature. So first of all, you have to decide on a variable. So the first variable that I might decide on would be T for temperature and then H for hour. So H for hour, and you can either do T for temperature. I'm going to do T or C for Celsius if you want. Either one is fine. Just pick one to go with. So I'm going to write your input is your hour. That is your X value. So it is C of H is equal to. So we start at 17 degrees. That's my y-intercept or my starting value. And then it is increasing each hour by 2. So 2 per hour. Now we're going to list all my options because it says only for the next 5 hours. So at the 0 hour, we started at 17. And if I've done my equation right, we know that it goes up 2 degrees every hour. So I should be able to 1, 2, 3, 4, 5. So we should be able to prove mathematically that one of these others works out perfectly. So let's say I choose 4. If I put in 2 times 4 plus 17 for Celsius of at 4 hours, we're going to get an answer of 8 plus 17, which would then equal 25. So it checks. So here's my list of possible domain answers, my list of possible range answers, and I have proven to you that the equation that I wrote is perfect. So you're going to do the same thing when we look at 5, 6, and 7 in terms of trying to come up with what you see happening in each of those situations. Then I want to try to challenge you for some science. So if you notice here, independent and dependent, he wrote some Homer Simpson. So let me make this one a little bit bigger so we can read it. It says Smithers thinks that a special juice will increase the productivity of workers. He creates 2 groups of 50 workers each and assigns each group the same task. In this case, they're supposed to staple a set of papers. Group A is given the special juice to drink while they work. Group B is not given the special juice. After an hour, Simmers counts how many stacks of papers each group has made. Group A has made 1,587 stacks, and Group B has made 2,113 stacks. Identify the independent variable and the dependent variable. So we're going to say that the special juice is your independent, and it is affecting the productivity of your workers. And what you'll notice is I have highlighted in bold the 2 vocabulary things that you are choosing from. So as you go on to number 2, you can see that coconut juice and green slime are the 2 things that I've highlighted. And so one of those will be independent and one of those will be dependent. And that works all the way down as you go through all of the Homer Simpson's different options. So that's a challenge for you to try to see if you can apply those to a science activity. The ones that will be on the test will look definitely a lot more like these on the first page. So again, focus on these first and then try the challenge. Okay, good luck.